Okay, so there we go. So yeah, I'm. This is actually a dry run of a talk I'm going to give at RustConf. It'll probably end up being pretty different by then, based on how it goes now and your feedback, as well as whatever else I do. But I hope it'll be interesting. So I'm Niko. Yeah, I've been involved since 2011. The first thing I did was prepare 0.1. That is correct. I specifically helped to port Rust from being 32-bit only to 32 and 64-bit. Of course, now it works on many other numbers of bits as well as architectures and so forth. I wasn't, when I came into Rust, it had already been somewhat developed. We had gone past the stage of an OCaml compiler. We had a compiler written in Rust itself and so forth. And a lot of the core values, I think, were already in place, like kind of quality tooling and reaching out, strong commitment to memory safety and so forth. Or at least we were saying those things. We hadn't actually realized them. We didn't actually have memory safety, for example. And so that was one of the things that I was involved in, is helping move that from goal to reality. But lately, what I've been doing is something a little different. If you've been following the Rust RFC repo, and I'll forgive you, maybe congratulate you if you haven't, but you may have seen this RFC go by. So I've been working on a thing called project goals. And the basic idea is, what this RFC does is it lays out 26 goals, specific things we want to do over the next 6 months. And of those, 3 are kind of the flagship goals, meaning the ones that are expected to have the biggest impact and the biggest interest. And I'm going to go through those goals in detail, and sort of what they say about Rust and how they were chosen. But before I do that, I want to talk a bit about the process that got to this RFC and why I think that's interesting. So if you've been involved in Rust or following it for a while, you may remember that we used to issue roadmap RFCs. The last one was in 2021. And in the time since, we haven't had one then, right, for about 3 years. And I think we've really begun to feel that gap. It's become a lot harder to know what other people are doing in the project. And there's a sense that kind of everyone is off kind of doing their own thing rather than pulling in a coordinated direction. And I think that has some negative effects. So I wanted to try to bring that shared coordination back. But I want to be clear about something. Like, people doing their own thing is not bad. Actually, I think it's very good. It's kind of the magic of open source, right? That people can come with their own goals and their own interests and drive it. But I think you have to balance that. If you want to be effective and as well as welcoming and accessible, you have to have some degree of coordination, right? So the goal of project goals is to give us a process so that we can rally around common goals and also preserve the ability and encourage, in fact, maybe even make it easier for individual contributors who have some great idea that they want to pursue to take that idea and run with it. So how does it work? Well, it begins with a call for submissions. So in May, we posted this blog post asking people to open PRs describing a goal they would like to drive in Rust. And it was intentionally open-ended, right? So if you want to submit a goal, you don't have to be a recognized Rust contributor. Where the idea is kind of anyone who has an idea they would like to go to see happen in Rust can open a goal. Well, not exactly anyone. Anyone who has an idea and is willing to put resources to make it happen, right? And that could be time and energy or expertise. It could also be money. We saw some of that. People saying, "Oh, this is something I'd like to sponsor." And this is pretty important to me because I think this is how kind of product management in open source works. It's kind of people, companies, organizations, whatever it is, drive work that is blocking them, right? That they would like to see happen. And that sort of implicitly selects for the things that are most important to get done in some sense, because there's usually a huge host of things you would like to do in theory, but picking out which is the most important can be pretty hard. And so you have this kind of natural feedback mechanism. And that's the way I wanted this to work, that people would come and say, or organizations, as I said, might come and say, this is something I really feel is important for the work we're doing with Rust. So I'm important enough that I'm willing to put up some resources and get it done. Right? Okay. Now, when you propose a project goal, then there's kind of three main pieces that you have to describe. The first one, the motivation. It's very simple. What problem are you trying to solve? Right? And if you've seen the RFC repo for Rust, you'll know that that's kind of, this is in some sense the first half of a Rust RFC, right? Where a Rust RFC might ask for a general review of a finished design. This is like, before you've done the design itself, just lay out what is the reason you're interested, what is the problem you're trying to solve, and how do you roughly plan to go about it. Now, it doesn't have to be a language feature. It could be some kind of problem with Rust infrastructure, or maybe the maintainability of a common library or tool, or a social problem. In fact, it might not even be a problem exactly so much as an opportunity, right? Something we could do better. So I actually submitted a goal for running the goals process. So it can really be pretty open-ended. Now, the next thing is you want to include the next steps. What are some of the specific things you plan to do over the next 6 months? And we intentionally scoped it down to 6 months because that's a time frame where we can kind of reasonably predict what's going to happen. And it lets us kind of adjust course if it's not going the way we expected it to. But it's also meant to encourage us to think iteratively. A lot of times we get stuck. You know, you have a big problem you want to solve. It's really hard to figure out what part to do first. What I've often found is it actually doesn't even matter that much which part you do first. There might be like 10 things all worth doing. You have to do them all. And it can be very hard to pick which. Well, just pick one and do it, right? And you'll find out if it was the wrong one, but chances are it won't be because you've probably got better instincts than you think. But anyway, backing up, the goal was to say, hey, let's lay out exactly what we're going to do and let's go ahead and do it. And then let's stop, I guess, second guessing and trying to decide which other part to do and just get that one done and revisit it in 6 months. And the last part is asks of the Rust team's requests. So let me say a Rust team is the set of people maintaining some part of Rust. So for example, I'm part of the language design team. There's a separate team that makes decisions about the compiler architecture. I used to be part of it. I've withdrawn from that for time reasons. But there's also teams for managing Rust infrastructure, releases, the standard library. And there's a common misunderstanding, I would say, that a Rust team are the people who implement Rust or who do this development. In my mind, that's actually not the role of a team. I see the role of a team in open source is to support and review the contributors, and the contributors are the ones who do the work, right? And that doesn't mean that people on teams don't implement features or don't do the work, but when they do that, they're not acting as a member of the team. They're actually acting as a contributor. And so you can wear these different hats. And so the way I see it is the person who writes the goal is the contributor, or the owner, I prefer to call it, who's taking the work, owning it, seeing that it gets done. But what they're saying is a kind of contract. If I do this, if I put in my own time and effort to get this done, I need something from the team. I need support, right? And that could be different kinds of support. Sometimes it's as little as what we call, there's even this is a term in the thing, discussion and moral support. Meaning, I don't actually need anything from the team except sort of the team to say, yes, this looks like a promising direction, and if it works out well, we may be interested in incorporating it in the future, right? Or yes, we'll put in some time to talk to you about problems you hit, right? Because I know the work isn't going to be ready in 6 months to be included yet. All the way now, that's like the smallest ask, but the biggest ask might be, I need you to commit to review this and give me prompt feedback, or I need a dedicated reviewer because I don't really know my way around the compiler, and if I'm going to be effective, I need that, right? And so I'm really trying to get this kind of discussion rarely happens explicitly in the past, so I'm really trying to bring it more to the fore and have it be something we actually talk about. All right. So enough about process. I can geek out on open source process for a long time if desired, but let's look at the actual goals, right? What are the things that we said we were going to do over the next 6 months, and what do they tell us about where Rust is and where it's going? So the first one, I'm going to go over the flagship goals. And the very first one was prepare for the Rust 2024 edition. So what is that actually? I think a lot of people here may not really know what a Rust edition is. Rust editions are the way we have found to let us make what would otherwise be backwards incompatible changes. Right? One of the key Rust values is sort of delivering iteratively and incrementally and growing the language as we go. And in order to do that, we have to sometimes make decisions, and sometimes those decisions in the full, we see with hindsight might have been done better a different way. And so additions kind of let us do that, but they're very carefully designed to not cause the kind of ecosystem splits and damage that we sometimes see happening elsewhere. So let me show you how it doesn't work. Right? This is not what we're doing. One thing we could do if we wanted to make a backwards incompatible change is we could declare a Rust 2.0 compiler that compiles things in a new way and doesn't accept the old programs. Right? And the problem with that is, imagine you have out there in the ecosystem sort of a bunch of code for Rust 1.x, like SurrealDB is a library for serialization, and you have your crate, and then you port your crate over to Rust 2.0. The challenge is now all of your dependencies also have to be in Rust 2.0, or else your crate is not going to work. Right? And that's super annoying, and that creates this kind of split that has to be healed over a very long period of time. But there's an alternative, which we call additions. And the idea is, okay, today all the code out there is running in Rust 2021. Well, we're going to release Rust 2024, and we're going to let you move your crate over to Rust 2024. But the compiler continues to support all the old additions as well, right? And in some sense, the addition is just like a front end that compiles down to the same thing afterwards. They can interoperate. And that means your crate, it doesn't really matter whether SurrealDB is in 2024 or 2021, you can go on using it. And in fact, it can go the other way, right? Maybe SurrealDB goes to Rust 2024 because they're excited about it, but your crate, you don't have, for whatever reason, it doesn't fit your schedule, you don't do the migration yet, that's not an issue for you. You can still consume it. So that's kind of our goal, that everybody can move at their own pace. And we do expect everyone will eventually want to upgrade, and we design for that. But we believe they'll want to do it on their own schedule when it makes sense for them. So what are we actually changing? We're not making a lot of changes in Rust 2024, but I think that, and sort of our goal is never to make a lot of changes, right? That would mean we're making sort of decisions that often have to be revisited. It's not our goal, but the changes we make, I think, can have a pretty broad impact, and especially around, usually what the goal is to increase consistency and learnability, right? To address specific sort of usability challenges we've seen cropping up. And here's one of the ones we're looking at now. So if you know a little Rust, you probably recognize this kind of code. What this says is we've got a function. It takes a slice that is like an array of datums, some kind of data, and it returns an iterator of processed datums, right? And that means it returns something that you can one at a time do this processing, pull each datum off. And you see that it's written with this impl notation, impl iterator. That means I return some value that implements the iterator trait. So let me actually pop up in the playground. And here's the code with a little bit of stuff in the bottom. And there's an interesting thing. If we actually build this code, what you're going to see is that it gets an error, and it's kind of a complicated one. Hidden type captures a lifetime. Okay, that's sort of a mess. You actually have to know some Rust concepts to understand what's going on here, and I'll explain it in a second. But it also gives you an error message saying how you can fix it. Right? So you can write this thing plus tick underscore, okay, and then you can build it, and hey, now it builds. Okay, so what's happening? Well, what's happening is when you call this function, you're saying you return some kind of iterator, but by default in Rust today, we assume that this value you return does not hold on to the data that's borrowed on input. Right? So if you don't say anything else, it's assumed not to capture borrowed data. So that means that the caller who lent the data to the function can then go ahead and immediately start using it and owning it and modifying it and so forth. But what we actually need is, because we're returning a reference to this list of datums and we're going to process them kind of lazily as the caller processes them, we actually need to hold on to that. So that's what this plus tick underscore does, is it signals to the compiler, actually, I'm returning an iterator, and it's an iterator that holds on to this reference. And the underscore is sort of a shorthand. You could write it more explicitly like this. And this would be saying, I'm holding on to any data tagged with tick A, which is this one. It turns out, this is a pretty common pattern, but it turns out you can see why it's a little bit subtle and complicated, right? And it turns out we're not entirely consistent about it. So for example, we have async functions, which we're going to talk about later. And I guess Caroline's book, forthcoming book, will tell you all about it. But this we tell people essentially desugars, right? So if you write an async function, that's like saying I have a synchronous function that returns a future, some kind of future. But it's not exactly true. It's actually a future that may capture all the arguments. So in reality, it's more like plus tick underscore is what we're actually doing, but we're hiding that from you and making it simpler for you. This is all in Rust 2021. So what's happening in Rust 2024? Well, we're going to unify these concepts. Actually, you can try it out today, right? So we saw this is the same link, it gets an error. But if I go over here and I switch the edition to 2024, and now I try to build it, hey, it compiles. Why? Because we changed the default, basically. We said, you know what? Actually, what we've seen in the ecosystem is people always want to capture, or often at least, want to capture all the data. So that's the default. And then we added a new way, which I won't go into right now, for saying that you don't want to capture things. And that's, so it's a small change. It's in the edge case, but it brings Rust into a more unified, consistent whole, right? And so I think if you ask, what does this goal say about us that we chose it? Well, I think it says, hey, we're not done. We're going to keep working on Rust, despite the fact that Rust has grown a lot over the last couple of years and has gone from sort of hobby project to running big parts of the internet. There's still work to do to make it much better, and I think we're still going to keep doing it. Basically, we want to see it become ergonomic, easy to use, and as accessible as it possibly can be. All right, so what's flagship goal number 2? Bring async Rust and sync Rust closer to parity. So what is this? What is async Rust? Well, it turns out Rust has gotten to be a great fit for building network systems, right? And I'll go in a little bit into the reasons why, but this has become a really popular application area for Rust. I think 52% of the people in the survey said that this is what they're doing with Rust. And a big part of that is this idea of async Rust, which is what introduces the async await notation that you've probably seen in other languages into Rust. So it's a way to give you more flexible control flow. And the reasons why Rust has become so popular in this area, well, I think it's a combination. I mean, one big one is something called tail latency, which is basically like the P99.9 percentile of how long your requests take, right? Basically, how slow is your slowest request? And that turns out to be, if you're building up a high scale or an at scale data plane, that turns out to often be the kind of dominating factor for how many machines you have to use, because you really want to make sure that the worst case experience is still pretty good. So you end up scaling based on that, not based on your average performance. And since Rust doesn't have a garbage collector, you don't hit garbage collection pauses. We also just don't have much of a runtime in general, right? So you don't like have JIT compilation issues or other kinds of things that can lead to unpredictable tail latency. We have a much more flat, even performance curve. That's great for really large scale systems, but it's also really popular in small scale things like function as a service, sort of Lambda or Azure Functions or whatever. And that's kind of the same reason, but flipped, right? Rust doesn't have much of a runtime, so it starts up really fast and goes fast from the first second it runs. It doesn't, the no garbage collector keeps memory usage low, which means you end up paying less. So it can kind of control costs in these small scenarios as well. But I think the other part of it that I hear a lot that's maybe underappreciated is reliability, right? Network services especially need to run 24/7. They have any bug you can catch up front is a bug you won't get paged about later, right? And so Rust type system, although its primary purpose is to prevent memory safety errors, also prevents a lot of other bugs. You don't get null pointer exceptions. We prevent data races, so you don't forget to lock your data or anything else like that. And you can often model parts of your domain in the type system. So you can sort of prevent bugs like forgetting to convert from euros to pounds or whatever if you give those a distinct type. And that stuff is very lightweight and easy to do in Rust. And so I'll put that all together and you get this kind of, if it compiles, it works feeling that actually is true more often than it has any right to be. The challenge here is that async Rust is still kind of challenging to use. As someone once put it to me and I really liked it, it's Rust on hard mode. And a big part of that is that we haven't really finished implementing all the features yet. It turns out it's pretty tricky. There's a lot of stuff to work out to allow this async await notation to kind of work its way through the Rust system. So what we want to have is this feeling, right? We want you to basically say, okay, if I want to use async Rust, I just put async in front of my function. I just await when I call that function and everything kind of works like expected. But there's a bunch of places where you can't actually have async functions or you can't actually have awaits that you would like to, right? And this is kind of my list. We've been working on this over time. Last year, we closed up async functions and traits. And this year, the big marquee sort of feature is to implement async closures. So I'll go briefly through it. This is an example of a synchronous closure. So here we have a function. It's calling this execute function for every prime number. And I guess this isn't a very scalable implementation since there's an infinite number, but whatever. So this is how it would look if you were writing synchronous regular Rust, right? And today, to actually write this in async Rust, there's kind of no good way. It's very complicated. I'm not even going to show it to you. But if you use the nightly compiler, it just looks like this, right? I put async here. I put async in front of my fn to say, hey, this is an async version of a closure. And then I cut await after each call, and it works, right? And that's the kind of feeling we're going for. The other advantage of doing async closures that's sort of strategically important, besides just making it easier to use Rust, it opens up a bunch of APIs that have previously been kind of blocked because they wanted closures and we didn't have them. So, okay, what does this goal say about Rust? Well, I think it says, hey, fearless concurrency is super important. This has always been one of our slogans. And what we're seeing is that was a good call. In some sense, if you really want to scale up and scale large, you need concurrency and parallelism. And Rust has strong support for that with the type system being able to prevent kind of common bugs and so forth. And if we can make async Rust, if we can finish this journey and integrate it fully into the language, I think we will find that this will be just a great, hopefully a great way to write applications like that. Right. Okay. So let's go to flagship goal number 3. Bringing the Linux kernel closer to building on stable Rust. So what is this all about? And why should you care about the Linux kernel anyway? So the Linux kernel recently has adopted experimental support for writing components in Rust. And what they've been doing is actually pretty exciting in my mind, because they're not just sort of, so if you know much about Rust, you'll know that it has this unsafe Rust superset, where you can sort of write Rust and then you can say, hey, actually compiler, like, chill out, don't look at this part of the code, I got this, I'm going to manage it myself. The problem with that is you're basically back to writing C code now, right? And sometimes that's good because you want to, this lets us kind of keep the core of Rust small, but lets people extend it in libraries and elsewhere. But sometimes that's not so good because, well, you have all the bugs and risks that make writing C code a very challenging proposition, at least productive, reliable C code. And what Rust for Linux could have done is just said, we're going to expose a pretty C-like superset of Rust. And there are some projects that do this, and it actually makes a lot of sense because Rust has a lot of productivity features that C doesn't have. So, even though you don't get a lot of memory safety, you can still get advantages from using Rust. But that's not what they're doing. What they're doing is looking to build actually safe abstractions. So to take that unsafe sort of capabilities and put them in a wrapper that prevents you from making common mistakes and keeps the kernel from failing, right? And that's the really good way to use Rust. That's what gets you the like multiplicative productivity advantages. And what also has this effect of opening up systems programming and making it kind of worthwhile to a larger set of people, right? I'll talk a little bit about that later. The challenge is, in order to do that, they're hitting some roadblocks because there's a lot of Rust features that they need, which we haven't stabilized, meaning we've implemented them or we've got a rough draft, but we haven't made it available in stable Rust for widespread use. So that's blocking them. And it's not blocking them from making progress, but it is blocking them from getting this feature out from like little experiment to something that can be widespread used, right? And there's a lot of practical reasons for that. Basically, in order to use it, in order to build the Linux kernel with this feature enabled, you have to use the latest version of Rust, the nightly compiler, which is not necessarily available. And so if you're someone who doesn't know anything about Rust, you're like a kernel developer and you're just used to building in C, having to go find out what version of Rust you should install and so forth is a huge hassle. It's just going to make you immediately turn off, right? I think like one of Rust's selling points is like easy tooling. You don't have to deal with all that crap, but here you do. So we don't want that. And we want to support the Linux kernel work that they're doing and use it in some sense. Remember, I told you that open source prioritization works best if you have a customer kind of coming and asking and you can use them to decide what to do. This is a case where part of the reason all those things are unstable is none of us were actually using them directly, us in the core development teams. Or the people that were, so having the Rust for Linux folks kind of coming in and helping us prioritize, this is the feature we need. This one is done. Yes, I gained a lot of experience with it. I can tell you it's working, is really helpful with gaining the confidence that we are doing the right steps here. So what does this goal say about Rust? No limits. That's the way I see it. One of Rust, in my mind, one of our core values is like there's no limit to what you can do with Rust. You can start quickly, start easily, be productive early on, and get the compiler will give you the guardrails and help you get something out the door. But as you grow in your needs, you can take it all the way up to integrating into the Linux kernel, probably one of the most demanding applications, well, not probably, definitely the most demanding systems application I could imagine. And I guess I want to just circle back to that idea of high meets low, because I think one of the things I find most exciting about Rust, and what I mean by high meets low, is that you can build these really low-level systems like kernels in a high-level productive way. Right? And what I see that as doing is opening up, broadening the set of people for whom it's worthwhile to write that kind of code. And note that I say worthwhile, because we're used to talking about like systems programming wizards. That's a term people use, right? And the way I see it is there's nothing wizard-like about it. It's true that doing systems programming requires a lot of esoteric knowledge. So in that sense, it's arcane. But that's not. It's not that other people who aren't systems programming wizards couldn't learn that stuff if they wanted to. They could. They just know that they have a domain that they're focused on. This is not the highest value thing for them to do, right? It's more important that they get the web page up and going, or they get the product out and going. And so if they're not presented with a way to do that low-level programming, other than having to learn all that esoteric stuff, that's a huge hit and a huge blocker to doing that work. But actually what we've seen with Rust is when you make something accessible, if you say, hey, you can do low-level programming, and you can sort of start out with guardrails and then gradually, write your own components and your own unsafe abstractions when you need to, if you need to. There's a huge pool of people who are interested in that. right? And I think that the Linux kernel, my strong personal belief is that if they are successful in this work, which is super exciting, and other kernels too, if they're successful in making it possible to write Linux kernels in a safe way, Linux kernel modules, you're going to see an explosion of people for whom that's something that they think maybe I could do that, right? And we're going to see a lot more creativity and a lot more great ideas coming in through that route. So I'm pretty excited about that. All right, so that's kind of the end of my talk. I can see I went a little over. That's good, maybe. Well, whatever. Hopefully you're still here. So where are we going? Well, I think in the big picture, I think these three themes that I outlined are actually pretty good ones for us to focus on. We want to keep making Rust simpler. That's what the edition's all about. That's what a lot of our work is all about. Essentially reducing, in my mind, the goal is as we extend Rust, you can either add more and more that you have to learn, or what I'm really more interested in is finding opportunities to reduce the amount you have to learn, which sounds sort of paradoxical or oxymoronic, like you shouldn't be able to add things and then make it simpler, but actually you can, right? And we saw that with Rust 2024, where you no longer have to understand this discontinuity and infiltrate. So you can find ways to kind of add a unifying concept that makes everything fit together into a simpler overall whole. Async Rust parity or fearless concurrency, I think, is going to be a continuing theme. It's a hard job. It's been a heavy lift. It's really important, and we need to keep working on it. And finally, stretching where we can go and breaking out of those limits. And I think if we can do that, that's going to make Rust into what it's kind of striving to be, which is a place where people can get involved, follow along, and bring ideas from, I have an inspiration, to, hey, I have something in production as quick as possible. And I think that's true for the things you're building with Rust, but one of the goals of project goals is to kind of make that even more true than it already is. I have seen it happen a lot, but make it even more true for the open source Rust development community that are building Rust itself. All right, thanks very much. I'll leave it there and happy to take questions.
Great, thank you so much. That was amazing. I've learned so much, so I really appreciate you taking the time to come and speak to us. This is going to be put on YouTube, and I'm really expecting there to generate lots of discussion, and we know lots of people do check out the YouTube channel, so that's really great. If anybody has any questions, please put them into the Q&A in Google, and we'll come to it. And if I could just sneak in some questions beforehand, if that's all right, just while people get going. So I guess you said that there's 26 goals. Is that right? 26 goals.
26 total goals, yeah.
But we talked about the three. Well, you talked about the three most kind of top tier ones. I'm really excited to see all the stuff about async. That's amazing. What are some of the other goals, sort of briefly? Is there anything that you find personally interesting within that?
Yeah, good question. There's a lot that are super exciting, and I let me add one other thing I didn't put in the talk, but one of the other sort of side goals of the goals program is to make it easier for people who want to follow, who aren't interested in developing necessarily, at least not yet, but just want to see what's happening and follow along easier. So there's this repository, Rust Project Goals, and I have to rework this MD book, but that's okay. There's an MD book here with the sort of, this is where the planning was done, and now it's going to be up. I have to update it a little to reflect the fact that we actually did accept the RFC. I went on vacation for 3 weeks, shortly after it got accepted, so a little behind there. But you can see the full list here of goals, and you can also see that you can click in on any one of them, and here's the motivation and so on. So if you want to learn and go deeper into any particular area, it's all there for you. Some of the goals I think are pretty exciting. It's not so much about the work that's being done. I mean, there are some where the work that's being done is super exciting to me, like Polonius. It's been making the Rust borrow checker simpler, easier to use, has been a kind of stop sharing here, has been a kind of goal of mine for a long time. But there are some that represent the process working as designed that I'm particularly excited about. Like one is we have a goal around cargo semver checks, which is a really cool library that I recommend if you publish a Rust library, you take a look at. It helps you detect when you're publishing a new version of your library if you've made a breaking change for your customers. And if you meant to, that's fine. But if you didn't, you probably do want to know that. And Rust's type system is complicated, and some of those subtle change, some of things can be breaking changes that you don't realize. So it's good to have a tool for that. And what's cool about this is that's an independent project. That's not part of the Rust project, at least not yet. It's led by a man whose name I can't pronounce, Predrag something or other. But sorry, Predrag. But the hope is it will come in, right? It's a tool that everyone sees would be a really useful thing to have in Rust itself, but we want to see it bake and get developed out in the wild first before we bring it in. And so that's one of those discussion and moral support goals where it's not ready yet, but it is a direction that the Rust project is ready to say, yes, we would like it to be ready. And that part of why that goal is there is so that that can be made official, right? And having that be official means that Predrag and other maintainers of that tool in the future can go to funding sources and say, hey, there's a route for this. Like, this isn't just some random project. This is something that the Rust community wants and is aligned behind, and it's an official goal. And that is a big win when they try to sort of sell consulting work and other stuff. So I'm hoping that it will kind of help in this way foment and make it easier for people to convert contributing into a career, right? And so along those lines, there's another goal or two that I found really exciting, which were actually coming the other direction, having organizations come or companies come and say, this is work we want to see done, and we're willing and able to support it, but we want to know if the Rust community is interested, basically, and better align those incentives. And I think that's really important, because what I've seen as sometimes a failure mode in open source is it's really hard for companies to just know how to get involved. Like, they have a lot of Rust users, they see problems, they'd like to see them fixed, but they don't know. We're much more friendly and accessible to a random individual than we are to an organization of people. We don't have an established route for that, right? And so I'm trying to build some of those because I think they're pretty useful.
Yeah, that sounds very much needed and very interesting. I guess that's a different not problem to have, but like a different approach, individuals versus organizations. Yep. Has anyone got any other questions? Well, otherwise it will just be me having lots of questions. So I think you've already answered this slightly, but I'm sort of curious. We've got this, so all of the goals, I had this question, which is, do all the goals come from existing Rust maintainers, which I think you've answered, like they can come from individuals and they can perhaps also come from companies. But like, what do you think the split is? Is it a small group of people who are mostly contributing? Like, how I find it difficult to understand like how big the community actually is in terms of like who are the Rust maintainers. And
yeah, it's a challenging question. I don't know the answer to that question. We've been trying to develop metrics and things for this. It's not easy. So I think most of the goals came from Rust maintainers, and that's good. That's fine, and I'm happy about that. I mean, I think the idea was to help people expose the work they're doing. There were probably like some percentage that came from outside. I mean, one of the things I want to say that I liked doing, and I think we're going to have to get better at, but it was not something I foresaw as a part of the role of helping to run this program, but now I see it's really key, is actually being a kind of ambassador or bridge where like somebody would bring a goal that's like pretty vague and ill-formed. I want Rust to be easier to use, and here's 3 specific problems. And sometimes that's nonsense, but a lot of times, in this case, or in some cases, it's actually is someone who really has a lot of great ideas, but they're just not experienced in working through the community. And so your role then is to sort of be the liaison between them and the community, to break up that goal into actionable tasks, to go build consensus and see, okay, well, actually, part A I don't see that happening in the next 6 months, but part B will. And sort of, it becomes like a kind of front door of how to get into Rust. Because a lot of times people say if you want to get involved in a community like Rust, it's sort of all backdoors. Like you just have to kind of hang around and get to know the people. There's no obvious way in, and we've always tried to build front doors. We have the RFC process and so on, but I think I heard pretty clearly the feedback that we need to do more there, and so that's the goal. The other thing that I think is sort of subtle is for people like me who are paid by my employer to work full time on Rust, there's still a kind of challenge where, Amazon wants me to set goals. That's like what it is to be in a company, right? They want you to say what you're going to do that year. And the Rust community has traditionally like not done that. So there's a bit of like, well, if I say something to my employer, I have no matter how much I don't want to, there's a kind of a conflict of interest where I'm going to start pushing the community in that direction. And having this goal process lets us bring this out in the open and talk about it up front. And now I don't feel any conflict of interest if I say, hey, no, look, we all said this is what we wanted to do. I made plans around it. Like, let's push for it. Because I don't actually think there's a real conflict there. I think companies just want to know that, like, the same thing I do, which is that Rust is making progress and getting better. But it can turn into one unnecessarily.
I guess companies have their own kind of metrics that they want to hit, or they have like, employee plans for the year of like what they expect.
Yeah, I'm sure it depends. I can only speak from my own experience. I know that within Amazon, like our role is to make Rust better for Amazon developers by and large, though also for everyone. But the truth is Amazon developers are basically representatives of right. We have like 60,000 developers. They cover all the same experiences of people outside. So it's really just a way for me to get deep and personal with a particular cohort, learn what their needs are, and then take that back and work with people from other companies and other backgrounds and so forth, and build something that's going to work for everyone, right? So I think that's true for a lot of the people I know who work full time, that they're using their company as a way to learn really closely about the needs of Rust users in general, right? And that's what I want to encourage. I mean, I don't want companies to come in and add some weird feature that, turns Rust into their private plaything. That's nobody's goal.
So you've got a couple of questions. I'll just read the first one. I think you kind of answered this already, but can you give an example how you work out with organizations who propose goals, what their contribution to the goal, financial or other, should be?
I think we're still working on that, to be honest. I don't really feel we hit that problem yet. It was more like people who come and say, hey, we've got 3 developers we want to put on this. They sort of had a thing in mind. I don't know. I think that's going to be an interesting challenge.
Great. I've got a quick question, which is, what is the process by which something gets from a library into like standard library? So yeah. I'm curious. So we've been writing this async Rust book, and between the sort of original draft and the one that's just been submitted, once so like a lot of the syncing and the lazy lock or lock has now gone into sort of standard library, and I just realized I just had no understanding of like what that process was like, because I haven't come across that necessarily in other languages like Python, where something suddenly becomes like a really popular library becomes part of the standard library in the same way. Probably it does happen, but yeah, what's that process like?
Yeah, that's a good question. That has become more and more of a trend, especially in the standard library. And I mentioned it with the cargo Semver checks, right? That was sort of the plan. The process, I'm actually not super familiar with the library team's exact process. I know they have something, I think they call it an ACP. I forget what that stands for. But I can speak in general about how all the teams tend to work, and it's the same, which is, at the broadest outline, somebody submits a proposal describing what they want to do, and the team sort of reaches a consensus that this is a direction they would like to go. So for language features, that tends to be an RFC. But for the library, they have a lighter weight process where I think you open a PR. That's what the ACP is. Or if the PR is to forward, you open a change proposal. sort of summarizing the thing you kind of want to do in a high level of design. Then it goes into nightly, at which point it's available for everyone to use, but only on the unstable branch, and changes can be made. And eventually a stabilization report is written, which sort of summarizes the experience and what changes were made, uh, and requests to stabilize. And again, the team makes the final decision. At that point, it's available to everyone. So there's this kind of design, baking period, and then stable. What I think we have struggled with sometimes, there's different aspects of this that I would like to improve, and project goals is one of them, where at least some of the time I think it would be useful before that first step of writing an RFC or a change proposal to have, like, even writing that is quite a lot of work. So having some way to say, hey, I'm making a goal of, I want to write this RFC, that's my goal. But I want to know that the team is like interested in me doing that before I do it. But the other part that I sometimes see it as challenging is sort of directing user feedback in that baking period, and getting people to know, hey, this is on nightly and you can try it out and give us feedback and see that it's working. Does that answer your question?
Yeah, that's great.
Nice. Niko, thank you so much. I just see we're nearly at time, so I wanted to dive in with two final, like, really quick fire round questions, if that's okay, and then we'll wrap up. I know that Caroline could keep talking and ask you questions. Literally just had a fangirl moment. She just slapped me saying, I love him. So it's been, Niko, it's been amazing to see behind the curtain. It is so exciting to be really learning about how this language is being thought about and built. It's really invigorating. We had two final questions. So one is about the borrow checker and how it was to build that in a few sentences.
Oh, well, it's kind of a dream. It's definitely the kind of thing I got into doing this to do. And the cool thing about the borrow checker that worked for us, I guess I'll say one good thing and one different thing. The good thing is it was really interesting to have a huge base of code, which is what we did. We had the compiler, and we were trying to add a type system after the fact. And that's really hard to do, because if you build with a type system, you sort of structure the code in a way that is friendly to the type system. And I think learning Rust is learning how to do that, essentially. But what we didn't have that. So in some sense, we were looking for a type system that would actually fit our existing code, like 90%, so that we could do the 10% work to bring it over, and it wasn't like overwhelming, right? And so that's kind of a cool forcing function that I think also gave me some confidence that actually this does describe the patterns people use in code when they're just writing code normally without any expectation. So that's really cool. I just have tons of ideas on how to make it better. I'll just say, I wish I had, a time machine to go back and do it another 10 times, but I guess additions are the best thing, the closest we got. So.
Iterating is always the way forward, isn't it? Amazing. And the final question was, we often talk about this actually at these sessions, is how, if you have any good suggestions of how to introduce Rust into the companies that people are working at. We'd love to hear from the horse's mouth. Yeah, any good suggestions?
Yeah, it's a good one. It's a good question. There's a talk I recommend by Ashley Williams about how she introduced it at NPM. Really good talk. So in some sense, I'm just parroting what she had to say, because I think she was right on. But what she said there was, first off, reliability is more important than you think. I mentioned this too, but like a lot of times, actually things are performing okay. Like if you have a performance problem, that's kind of an easy case to make the sell for Rust. But a lot of times you don't. At least you don't know what's available to you. And so reliability turns out to be a bigger selling factor. I would say start small. Look for things like tools or lambdas, or like isolated systems that you can kind of move over and gain experience and use to help people get convinced. And iterate. Like deliver value as quickly as possible is definitely important.
Super helpful. Niko, thank you so much. It was really wonderful to have you join us. We hope we'll get you back again next year to do another talk, follow up, see how all of these new kind of implementations worked out, see what you're working on again for 2025. So, and good luck for your talks as well. I'm sure you're a very busy man kind of traveling around the world
Well,
doing
thank you
it.
very much. It was a pleasure.
It's been amazing to have you join us. So just as kind of a wrap up, for anyone watching, please do remember to join our meetup group, Women in Rust. We are going to be holding our community catch up on the 16th of September. This is where anyone can just come together and chat about projects you're working on, any questions that you have. Caroline or I will be there to chat. We also have our 3-part hybrid sessions, which are going to be focusing on Rust API. So we've got 3 of those hosted in London, but you can join if you're an online community member. And the final 2 points of action are to please get in touch if you have any recommendations for good speakers. We're always looking for brilliant people, anyone who wants to help us build out the community, no matter where you are. Obviously, Caroline and I are based in the UK, but Niko is our first guest speaker from the US, and obviously hoping to build out more there. We've just shared the type form, so please do share that and like and subscribe on our YouTube channel as well. And we look forward to sharing this talk, Niko, far and wide on there. So one final round of applause, and of course for Caroline